Okay, the last topic left in this section is solving inequalities using sign charts. Okay, so what's a sign chart is this tool that we use for analyzing graphs of functions, and in our case for solving inequalities really. We find where the function is 0 or undefined, then partition the number line into intervals at these points. Then we test each interval to determine if the function is positive above the x-axis or negative below the x-axis on those intervals. Okay, so the easiest way to learn a sign chart is to just follow an example through. So that's what we're going to do here is we're going to construct a sign chart. First, here's the 4 steps, and then we'll do an example. So step 1 is to find all numbers which are, well, points of discontinuity. That's where the denominator is 0. Or points where the function is 0, where the numerator is 0 but the denominator is not. Then we're going to plot these partition numbers, right? These are going to be called partition numbers, on a number line, dividing the line into intervals. For each one of these intervals, we're going to select a test number and determine if the function is positive or negative there. Then we're going to complete our sign chart by showing the sign on each open interval. So here we go. Here's an example. Let us solve this inequality. X squared plus 3x over x minus 2 bigger than 0. So think of the original problem as being for what intervals is f of x equal to x squared plus 3x over x minus 2 bigger than 0? Where is this function bigger than 0? The first thing we do is we factor out the top and the bottom so that they're simplified as much as possible, like you see here. Notice there is no cancellations. Okay, so let's keep going. What are the points of discontinuity? Well, the points of discontinuity are the points where the denominator is 0. That would be x equals to 2. What are the points where f of x is equal to 0? Well, those are the points where the numerator is equal to 0. That would be 0 or negative 3. Step 2, place these partition values on a number line. So here's our number line with 0, 2, and negative 3 on there. Okay, step 3, select test numbers and determine if f of x is positive or negative. Okay, and here's how to do this. For the first interval that we have, that's going to be the interval from negative infinity, all the way over here somewhere is negative infinity, to negative 3. So we pick the number negative 10 as a test number. So this is for negative infinity to negative 3. The second interval that we have is between negative 3 and 0. So between negative 3 and 0, we picked negative 2 to be a test number. Right? Here we pick negative 10. For the next interval between 0 and 2, we pick the point 1 to be a test number. And between 2 and positive infinity, we pick the value of 3. So this is between 2 and positive infinity. So that's how we break up our real number line into intervals using those partition numbers. And now for each one of them, all we have to do is plug this value, these test values, into the original equation and see if we get a negative or positive value. Okay, and I leave that to you to do. Notice there's a trick you could use, right? Since this is factored out, you could just sort of see if each one of those 3 pieces is going to be positive or negative. So for example, with negative 10, this over here will be negative if you plug in negative 10. You're multiplying by x plus 3, which would be negative 7, so this would be negative. And at the bottom, you're going to have negative 10 minus 2, which is also negative. So you have negative times negative, which is positive, divided by negative, that gives me a negative. Okay, so that's a shortcut you could use. You don't actually have to find the value f of x. You just need to know if it's positive or negative. Same story for negative 2. This will be negative. Negative 2 plus 3 now becomes positive. Negative 2 minus 2 is negative. So I have negative times positive, that's negative, divided by negative, that's positive. For 1, this would be positive, this would be positive, and this would be negative. Positive times positive is positive, divided by negative is negative. For 3, this will be positive times positive times positive, I get positive. So we get negative, positive, negative, positive. We could complete the sign chart by filling in the negatives and positives on the real number line as you see here, even though it's pretty clear what you're getting as an answer, right? It's pretty clear what for which interval what's happening. Okay, so remember the plus signs mean the function is above the x-axis, while the minus signs mean the function is below the x-axis. Of course, you could check your answer with a graphing calculator to see if what you get is the same, and in fact it is. Okay, with that in mind, The bigger than 0 in the original problem means the solution is the intervals where the function is greater than 0, right? Remember, the original problem asked you, when is this bigger than 0? Well, you look at the intervals and you pick the ones that have positive signs, pluses on them. That would be negative 3 to 0 and 2 to infinity, right? So this is negative 3 between x and 0, or x bigger than 2. In interval notation, we write negative 3 to 0, union 2 to infinity. Okay, so that's how you do a sign chart. And here's the summary for this section. We've developed a definition for determining if a function is continuous. That is, the function has no holes or oddities. We have developed a set of properties for limits, and we have used sign charts to solve inequalities.